Now, okay, welcome to lesson 3, and this is the main stuff. Here we're going to look at river landforms. So, river landforms, very important. River processes and landforms. Okay, so quickly, what are the river processes? I think we've done that in previous class. The processes of a river are erosional, transportational, and depositional, and you have different features or landforms that are formed as a result of erosional process. So as a result of erosional process, we have things like potholes and waterfall. We're going to look at those two. Transportation, we look at meanders and Oxbowlake. Then deposition, we look at deltas, levees, and floodplains. Now, if you can't understand what a river profile is, both the long profile and the cross profile, please watch lesson 2. It was explained in lesson 2. So let's move. The first one we're looking at is potholes. How is a pothole formed? Now, firstly, this is how a pothole look like in a riverbed. So these are potholes here. These are potholes. These are potholes. So how is it formed? Firstly, you see potholes are round oval shaped holes in the bedrock of a river. So you find out that this is the bed of a river. So the rock here are called bedrocks of a river. Now, they are created where sediment accumulates within naturally occurring small depressions on the rock surface of a riverbed. So, sediments like small rocks, rock particles, and sand, shingles, all find themselves inside small natural depression like this. Now, so you have turbulent flow, we swiddle the stone called grinders. So these stones inside will now occur as turbulent flow where the water move in this pattern will occur within those small depressions. So once that happens, abrasion is what will take place, like sandpapering, where the stone rub against the rock or the bedrock, making it what to become wider and deepen more. So as the hole gets bigger, even bigger debris can now be trapped within the pothole and make it larger through this abrasive tool. Remember, abrasion is an erosional process. Okay, the second landform here is waterfall and gorges. Now, so waterfall is formed when hard rock overlies soft rock layers. So hard rock, you should remember that hard rock overlies soft rock layers. So here, if you look at this animation, you have this is the hard rock here, hard rock, and this is a soft rock. So the hard rock overlies a soft rock layer. So hard rock is resistant to erosion, but soft rock is not. So the soft rock will be what? Eroded through the process of hydraulic action, which is the force of the moving water, abrasion, which is when the particles rub against the bed and the bank, then corrosion, which is also referred to as solution. So once the soft rock get eroded, it will now form, leading to the formation of an undercut. So this part here that is being eroded forms the undercut. So here, as the soft rocks get eroded, this will now lead to an undercut. Now the undercut will now form an overhang. An overhang is the hard rock that is left behind without any support. Remember, the soft rock was here initially, but now there is no support because it has been eroded, leaving this hard rock standing on its own. So that hard rock will now form what is referred to as the overhang. So the impact that we now have is that the overhang will no longer have support. So it will now fall into where it is called the plunge pool. So the deepest part of a waterfall here is the plunge pool. So once it falls into the plunge pool, you find out that these materials get into it. As it falls into the plunge pool, the waterfall will now retreat backward. As you see within this mini animation here, it will retreat backward, then the process will now start again. Now, but once it retreats backward, it will now form what is called a steep side gorge. So this place will become steep, it will be gentle, forming a steep side gorge. Then this process will now continue over a long time to form what? An extended gorge. So the retreat of a waterfall is a gorge. Take note about that, because it tends to be very confusing sometimes because both of them goes hand in hand. So when the waterfall retreats, it forms a gorge. Then this hard rocks that fall into the plunge pool, we undergo through abrasion to make the plunge pool, that area, deeper, because turbulent flow where the water will be moving in this pattern can also still occur within that point. So that is it. So this is how a waterfall looks like in real life. So you can see earlier this waterfall is somewhere here, but it has now moved backward. It has been eroding, and it's moving backward. Now, so this area now is the gorge, where the water has retreated backward. Then this point will be the deepest point, called the plunge pool. As you can see here, these are hard rocks. So the soft rocks are being eroded gradually from this point and undercut. So you can see these are the undercuts here, which this will now begin to collapse over time. So you have undercut. So this is it. This is why I love geography. It's everything you learn can be seen. Now next is Meanders and Oxbowlake. I tend to use a very clear I'll show you pictures of it, but I need to explain how a meanders is formed. Now, it's very simple, but I tend to see students confused about it a whole lot. So you see, a meander must be formed before an oxbow lake. So how is a meander formed? A meander is, when you want to describe the formation of meanders, you should remember this. Outer bend, inner bend, you should remember erosion, you should remember deposition, you should remember okay, for formation of meanders. So when you look at the cross section of a meander, I'll explain some other things we need to look at. So this is how it's done. If you have a water flowing in this pattern, okay, now, so what happens is, at the outer bend you have erosion, at the inner bend you have deposition. Now, deposition occurs when there is high level of friction, and this area, because of there is deposition, the area will become shallow. It will not be deep. While here there is less friction, so erosional process can occur. So it's formed through erosion and deposition. So as the water move, you need to identify where is the outer bend and where is the inner bend. So here is the outer bend. So here forms the inner bend. So obviously here will now be outer bend, and here will be inner bend. So as the water move, there tend to be erosion, so it will move towards this part here. So there will be erosion in the inner bend, so materials will tend to be deposited here. So erosion at the outer bend, and deposition at the inner bend. So as it moves, there will be erosion here, erosion at the outer bend, deposition at the inner bend. As it moves, there will be erosion at the outer bend, deposition at the inner bend. Erosion at the outer bend, deposition at the inner bend. So that is the formation of a meander. This will lead to the formation of a meander. As cool as it sounds, you get. So if they ask you, that is all what you just need to describe. So let me just read it now. So you see, I'll go back to that diagram. So there are areas, there will be areas of both fast and slow flowing waters. Yeah, fast flow at the outer bend, which is erosion. Now, so because there is erosion at the outer bend, what will happen? The water is deeper, there will be less friction. That is it. Now, and because there is less friction, you find out that an undercut can easily form at that point. And this outer bend, the water is being eroded by erosional processes like hydraulic action, abrasion, attrition, and solution. Then slow flow at the inner bend, where the water is what? Shallow, and there is more friction, which results in deposition river, and it forms what is referred to as a slip of slope. That is it. Then when you are asked questions relating to the cross profile of a river, now of a meander, now this is it. So a cross profile is when we decide to look at the river from this point to this point. Possibly we have point A and point B. We are looking at how features form from this point to this point. How does it look like? Now the first thing you need to know, material is deposited here, and because materials are deposited here, this area is shallow, it's not deep. So you find that if we look at the cross profile, let me say here is A and here is B. Then if I start from the outer bend and I move to the inner bend, what we have is the water we tend to move from, let me draw this as the channel between the two banks. So what we have is the water we move tend to be you'll have something like this. This is outer, this is inner, because here there is deposition. So you expect that it will not be deep, it will be shallow. Then the water is moving, is flowing here. So what I now have here is deposition. So there is deposition, there is friction. So it is not deep. So it will now form what is called, as the water moves downward, you see here is gentle. So that is what is referred to as the slip off slope. But here, you see, the water has been moving, so erosion is taking place here. So this point, you can have an undercut. Then here, you now have a steep slope. And this top here will form what is referred to as the river cliff. That's it. That's the cross profile of a meander. So that is what they are trying to explain here. So here form a slip-off slope. This is the outer bend where deposition is taking place. Here you have the fastest current called the talweg. Here you have an undercut. You have a steep slope, and this point will form the river cliff. So that's it. This is a meander in real life. So if you look at this meander here, you can tell that you can see deposition occurring here. This is deposition at the inner bend, and this is erosion here at the outer bend. This is still outer bend, erosion, deposition here. So if you draw the cross profile, you find that it will now be, here will be shallow. As it goes down, it will be deep. Then it comes back up. So that's it. So cross section of a meander, I've explained this. So you can pause it and read, but I think I've explained it. This is a past paper where you see X to Y and what are the features. So if you look at this insert, you find out that here is the inner bend. So what is happening here is deposition here. Then here you can see the undercut here. So there are undercuts here at Y. So it's the outer bend. Then you see this, you can see it's vertical here. So it forms a steep slope. And here it is gentle, moves downward this way, forms a gentle slope. So here will be the river cliff also. This will be the river cliff, steep slope, undercut. So they ask you for the features. It's that simple. Then an Oxbowlake. So an Oxbowlake is formed. Should I use this? Okay. An Oxbowlake is formed when the fastest flow of the water on the outside bend, erosion on the outer bank will make the neck to become more narrow. So as the outside bend keep eroding, the neck will become more narrow. So if there is flood occurs, you find out that it will now cut through the neck during what? Flood. And once it cuts through the neck, a meander will now be sealed by deposition. So the cut-off meander is referred to as an Oxbowlake. So if you look at this diagram now, you have, this is the neck. So you have, this is the outer bend and this is the inner bend. So deposition is occurring here, the yellow part, please. So as this river keep eroding the outer bend, so as it keeps eroding the outer bend, eroding over time, as it keeps eroding the outer bend, they become very narrow. The neck get narrow. Then during flood or something, the neck will now what? Sealed, will join together. Then the water will now follow a normal course, leaving behind this old meander to become an Oxbowlake. Okay, formation of delta. This is quite straightforward. I think I've explained the most difficult aspect here. Formation of deltas. Deltas is formed when large amount of sediment are carried by the river. Now, when the large amount of sediment are carried by the river and the sediment are deposited in the lower course, so deposition occur in the lower course when the river doesn't have a lot of energy to keep moving this material. So deposited material are not washed away, so due to lack of current or energy of the river. So therefore, making the river flow slowly. Then flocculation also can occur due to most river flows into ocean. So the salt content will make the material to also deposit. So deposited silt block the course of a river. So the river will now split into distributaries, forming a delta. Okay, let me just quickly explain some certain things about it. Let me clean this. Sorry, I'm taking your time, but I feel you need to understand these river features in detail. Okay, so in this aspect of a delta, let's say as the water is moving from the upper course, is flowing down from the upper course, so it carries rocks and materials along with it. Now, so as it's coming, it gets to the where the mouth is coming close to the mouth of a river. Now these materials begin to deposit. It deposits because the river does not have enough energy to continue moving the materials down course. Now it also deposits because of flocculation. So this is now deposition of these materials. So deposition of the sand and shingles, rocks carried by the river. So this will now, it will now do what? It will now interrupt. It interrupts or it hinders. It hinders the flow of the river. So once that is done, you find out that the river will not be able to flow using its normal course. So it will now break into smaller pieces, looking for space to move into smaller part. And this breakaway part is now called distributaries, which is now a delta. That's it. So what we're looking at is this. That's how a delta is formed. So with that explanation, you can actually still pause and read it. Then lastly, we look at floodplains and levees. These are the large depositional landforms formed by a river. Now, floodplains and levees, remember, they are formed at the lower course of a river. So, and at the lower course of a river, you have lateral erosion. So they are formed from lateral erosion. Now, deposition in the channel on the bed of a river, and also as a result of displacement of water. So flooding of river and the water overflows its bank. So when water moves out of its bank, from this diagram here, you can see these are floodplains and these are levees, which is at the bank of a river. So as these materials carried by the river due to lateral erosion, the materials tend, when the water flow outside the bank, maybe during flooding or during excess rainfall. So flooding of the river, the water overflows this bank. So in this second part, you see that the water has overflowed a bank of a river, so carrying large amount of sediment. So the sediment carried by the river as it overflows this bank, you find out that the heavier one tend to be deposited at the bank of a river, while the smaller, smoother alluvial materials can be moved further away into the floodplains. So you see the materials here. Now, so you find out that slow moving water, due to the water will move slowly due to friction, so it will not have enough energy to move the material back into the course after the flood. So deposition of sediment on the floodplain in layers. So the heaviest material is deposited first, nearest to the river channel, forming what is known as an embankment or a levee. So you see, this is the levees. Over time, you have layers of these deposited materials forming a low floodplain and a raised riverbank called a levees. That's all about river landforms. So next we'll look at river opportunities and flooding.